So you decided to build your own image model, which is almost 80 billion parameter, and you spent 2 years on it and spent tens of millions of dollars to build this particular model. And at the end of this day, you created this model and compared it with the closed models that is available for you. And you found out that this particular model basically ties with all the closed models. And still, even without winning this particular benchmarks, you decided to publish this model. This is what I found out in Hunyuan 3.0 model, which was published back in September 2025. So that's when it piqued my interest. So I went into the code, the architecture, as well as the benchmarks. And finally, I found out the tricky part doesn't lies in the benchmark, but in the architecture itself. This was not an image generation model. This was a chatbot which hallucinates images, and that is on purpose. So today I'll be discussing about this particular model, which almost changes how we define an image generation model. Most of the models that you might have seen generating images are diffusion models. These are like specialist models which gets a text embedding and denotes the pixels to give you an image. So what is wrong with these kind of images? This model does not understand, it has never read a book or never read anything at all. So it does not understand what is happening inside it. It knows things inside the object or inside the frame, but it does not know how it acts. For example, you say two tennis players playing tennis. It knows that there are like two tennis players who are playing tennis, but it might miss the detail. How are they going to play, or how are they going to place themselves within the code to play this tennis? So that's the major issue that usually these diffusion models face. And usually when you have a diffusion models and a chatbot with you, what you do usually is to connect these together to build a diffusion or image generation model by combining this together in a pipeline. That's what actually people do. And Tencent has both of these models. Hunyuan 13A model, which is a chatbot, and Hunyuan 2.1, which was a diffusion based image generation model. But they throw away this pipeline to create an entirely new concept to build this particular model called Hunyuan 3.0. So basically, one problem arises when you convert this chatbot into an image generation model. Like I said, this chatbot is the image generation model itself. It has the same context, it has the same weights, and it works on one CPU alone. So this is a chatbot acting as an image generation model. So you know that chatbot predicts the next word based on the words it has seen or from a list of words. But how do we generate pixels? How are they interrelated to each other? Is it based on the previous image or pixel it has seen? Let's figure it out. So in the last section, I said that the text models generally needs or looks into the previous prediction to create the next token. And how do we solve that particular problem? To generate the image using the same weights and the context within one CPU. So basically, what they do is pretty much simple. They use the usual causal attention to go over the text, and they use the same attention to go over the images as well. The only thing that they changed is to change the mask from triangular to square, and that's it. That's basically 3 lines of code that is being changed. So basically, the text generated before the image cannot see what's happening in the image, and the image is generated based on this text, but the text after the image can see the whole image together. So that's the basic concept behind this particular model. And once you think about it, it's pretty obvious, it's pretty simple. It's how usually the text model also works. And the other part that you might have seen, what you can see in this particular model is that while training, there will be lots of images that are generated in between. This could be false images that could have got given out false positive and all. And these in between images or results are discarded. And why do they do so? It's pretty much simple. The images that are created in between could give you the wrong idea for the model, and this could be not informative for the model to create the final results. So these intermediate results were masked and discarded. And following through, you might have seen the how you predict a text. It's basically depending on the position 1, position 2, position 3. That's basically a one line grid, but that's not how the usually how the images lie. So how do they solve it? That problem was the next question that came to my mind. So the position of the tokens became the huge question that came to my mind next. So like I said, in generating a text, you always keep the text within a grid, not in a grid, in a single dimensional array, which comes like position 1, position 2, position 3. But that's not how pixels works. It works in a grid of 2D plane. So how do you point these images to this plane, and how do you handle text within this plane? So that question was pretty much neatly handled by the Hunyuan team, because they were trying to not completely retrain a model, but fine tune this their text model to generate both text and images together. So what they did was really pretty good ingenious. So they added this rope mechanism, which is usually used. You don't have to know the mathematics behind it, but the rope is a methodology that is used to generate or find out the position of the token. So it is called rotary position embedding. You can figure it out later. But they extended this rotary position embedding to a 2D grid where the text tokens are lying in the diagonal space and the images lies around it. So basically, when you generate the image, uh, it uh, it fills the entire 2D grid. But once you are filling out the text tokens, it fills out diagonally. For example, 0, 0, 1, 1, 2, 2, 3, 3, like that. It just goes diagonally. So you just need to calculate one position for both text as well as the images. So it's pretty much simple. You first can look at the position of the text, then image, then text, then image, like that. So that sounds neat right now, but when you think about it, someone had to sit and go through the idea to figure out how these images and text can be bring together. So from the start of this video itself, I was telling this is a 80 billion parameter model. It sounds really large and misleading at the same time, because to be frank, of course it is an 80 billion model, but it is only 13 billion active parameters at the same time. And how do they do that? So basically, here is how the Tencent team handled the whole feed forward network in this particular model, because in the feed forward network, it's not the whole 80 billion parameter model, but it's called something called mixture of experts. So imagine each expert as a specialized at something, maybe at text, maybe at the texture, maybe at the images, maybe at the color pattern. So there were like 64 such experts in this particular model, and only 8 were selected by the router at the same time. I mind you, the importance at this model does not go for the expert, because each of the experts might look entirely the same, but the router decides which particular expert gets selected at each time. And this, after the training, the fascinating part that was noticed by the researchers for this model is that the particular router, after being trained, divided the whole experts into different scenarios, where some of these experts got selected for generating text and the other section got selected for generating images. Have you seen this pattern somewhere else? Yes, that is somewhere pure biology. That's your brain, because our brain is divided into different sections to handle different cognitive activities. Just like that, this particular image parallel to our brain got defined to generate both text as well as image automatically. And to be frank, the researchers never labeled you are an text expert, you are an image expert, or anything like that. It just happened over the time, over training. And gradient descent did that work for these researchers. Fascinating, right? And while training this model, Tencent engineers made sure that it gets very much filtered data. They removed lots of data from the internet, like the unclear ones. Those are like have labels, and those were synthetic ones which were generated by another models, because these synthetic models could have influenced this model to reinforce the mistakes that might have happened for these synthetic models as well. So apparently the model worked well, And one more thing that they did was to add the language to this model. So when you ask this model to generate this something, they go through something called reasoning, that something that you might have seen recently. So basically, this model will analyze the whole prompt that you have, or the instruction that you have given to this particular model, like who is the player, where it is standing, how is he playing. So and it generates the images. And the fun fact is that the text guides the image, so that the model understands what is happening inside the image, and it knows what should be the output. And that is why this model is so special and so peculiar, for me at least. So I think this answers the whole peculiarity of why this model was released, even though this was tied with most of the closed models that was available in the industry at that time. This had a really unique architecture where you have the right to own your own model at least, and you don't have to depend on multiple models to generate the text prompts as well as the embedding and then generate the model. This was one particular weight model that could handle both text and as well as image at the same time. And this is why I believe Tencent was ready to go out there and tell, okay, we have something very interesting for you. This is a chatbot that generates image, and this is very different from the models that is already available there, but still has equal parity or equal accomplishments as all the models that is available in the market, and we are giving it to you for free. But at the end of the day, this is not a complete free model for you. You have the weights, you have the rights, but you don't have the training data, you don't have the training code, you just have the results at your end. So like I said, AI is growing drastically, enormously in a closed range. You can view it at an eagle eye view and learn from what is happening, what are the techniques they are using. Even though you might not have the resource or compute to do it, but learning this kind of stuff will intrigue your mind to learn more and analyze more and to grasp something out of it. If this video helps, I will really recommend you to like this video as well as subscribe to my channel, because I will be sharing what do I learn from these models, what are the new technologies I tinker with, what are the things I want to build out of it. So, and projects I handle day by day. So that's all. Bye. So you decided to build your own image model, which is almost 80